All right, sophomores. Sorry I couldn't be there today. I got stuck with jury duty. So, I'm teaching you by video on YouTube. Here we go. Feel free to pause this video. If it moves too fast, you can pause it throughout. We're looking at 7.5 today. Parts of similar triangles. By the end of this lesson, you should be able to recognize and use proportional relationships of corresponding angle bisectors, altitudes, and medians of similar triangles. So let's get right into it. Altitude, 7.8. Please feel free to fill out your notes with this. Again, pause the video if you need to. I'm going to go through a couple of definitions here. A lot of it should be review, though. An altitude, if you'll remember, is the distance, it's the height of the triangle. From the base to the tip of a triangle is an altitude. Okay? So if two triangles are similar, the lengths of those corresponding altitudes are going to be proportional to the lengths of the corresponding sides. Notice here that we have the altitude, AD, for our example, AD, the altitude, over the altitude of the second triangle, the similar triangle. Okay, AD over FJ is equal to any of the sides, but they chose AB here, so is going to be proportional to or equal to AB over that same side on the other similar triangle, FG. Now, could they have used AC over FH? Sure. Okay, it could be any of the sides. But notice here, we have altitude over altitude is equal to any one of the sides over side. If they are truly similar, then the altitude is proportional to the corresponding side lengths. Moving on to angle bisector, 7.9. Okay, if two triangles are similar, the lengths of the corresponding angle bisectors are proportional to the lengths of the corresponding sides. So again, this word comes up throughout geometry. Bisector, to bisect something means to cut it exactly in half. So if we're talking about an angle bisector, we're talking about cutting an angle exactly in half. Now, whatever cuts the angle exactly in half, the angle bisector, that is going to be proportional to the length of the corresponding side. So in this case here, notice for our example, we're going to look at the bisectors. The bisectors in this case are LP and RT. Okay, so bisector over bisector of similar triangles is equal to lengths of corresponding sides. Let me switch up colors here. So in this case, they chose side LM and side RS. Notice those two side lengths are corresponding. Okay, so side over side. What is important here to remember too is that if you'll notice the original thing that we put down here, the bisector LP, if I can get my pen to work here, LP of the first triangle, okay, is equal to, notice they put the LM on top or in the numerator in the second ratio because we're talking about this, the whole top, the whole numerator section of these is going to be the same triangle. So I guess you could say bisector of triangle 1, side of triangle 1 is going to be proportional to bisector triangle 2 over side of triangle 2. So make sure you keep those straight when you're doing this. Next we have medians. So a median, if you'll recall, is the line that cuts a triangle's side exactly into half. Okay, bisects one of the sides of the triangle. That is a median. In this case, our medians are going to be CD, which cuts AB exactly in half, and YZ, which cuts WX exactly in half. All right, so if two triangles are similar, the lengths of the corresponding medians are proportional to the lengths of the corresponding sides. So in this case, we have the median of triangle 1 over the median of triangle 2 equals, now we're going to go over to side lengths. I'm going to switch colors here. Notice we go back to our original. They chose side AB. Okay, so equals side triangle 1 over its corresponding side. Well, the corresponding side to that on the other one would be WX. So side triangle 2. Make sure they're corresponding sides. All right, so let's look at a couple of examples where this shows up. Example 1 says to find x. Well, first of all, what are we dealing with here? Looks like we are dealing with a altitude, right? Because we're looking at the height of this triangle. Okay, so remember, it doesn't matter which order you go in, just got to keep it straight. So altitude over altitude, it has to be equal to side over side. So let's do this. I'm gonna make this my triangle 1, triangle 2. So my altitude of triangle 1 is 16. Okay. My altitude of triangle 2 is x. I don't know that. That's what I'm solving for. That is equal to, well, let's choose the sides that we know. Hopefully they're corresponding. In this case, they are. So 20 and 15 are the corresponding sides. So we're going to start with 20 since we started with 16. Triangle 1, we're starting with triangle 1 here. So we're going to do 20 over 15. Now it's as simple as going back to our first lesson in this chapter, which is ratios and solving these things by cross multiplication. So we have 20x equals 16 times 15. I'll let you guys solve it from there, but you can find x once you know these rules about triangles. All right. So moving on, let's look at example 1b. So example 1b, for this case, we are also looking for x, right? So here we know that what's happening is that we have split an angle. If you notice this guy, each one of those two things are congruent, but we've also, scratch that, I apologize. It's talking about that full angle. This is looking at a median, my bad. We have these two things are congruent, these two things are congruent. That means that this line is splitting this thing exactly in half. Okay, so we're looking at a median here. So remember that median over median equals side over side. So let's look at the median of our first one. We get 13.5 over 9 equals. Now this is where it gets a little bit tricky here. We have to have a side over side. In this case, notice that x here is only representing half of this full distance. Okay, so since x is only half of this, we know that this whole side length, the whole side length, SR, has to be 2x. Okay, x there, this has to be the exact same since they're congruent. So we know that that's going to have to be 2x, and then we know on our other one, if half of the distance is 3, the full distance of UV is going to be 6. So now we can cross multiply that out. So we get 2x times 9 equals 13.5 times 6. So I'll let you guys finish it out from there. All right, next we have 7.11, theorem 7.11, triangle angle bisector. So if you have an angle bisector, such as the case here, what it's going to do is it's going to separate the opposite side of that thing. Okay, so in this case it's side KL that we're talking about. Okay, it's going to separate that into lengths that are proportional to the lengths of the other two sides. So what that means is, when you have an angle bisector, if you look at the sides opposite of this thing, so that would be Km over Lm, that is going to be equal to the sides that go along with those. So notice that Km is on this side of the triangle, then this side that goes along with KM. Notice it's just like cutting this into two triangles pretty much. So if you think about it, cutting it into two triangles, the triangle that goes with KM, that side opposite would be side JK or KJ, how they wrote it down here. So KJ over the opposite side on the bottom half of the triangle, which would be JL. Okay, so what this is saying, again, is if you have an angle bisector, the opposite, if you look at where the angle bisector line cuts the opposite side of the triangle, those two pieces that are there, in this case KM and ML, those two things are going to be proportional to the other side lengths of the triangle. Make sure that you keep them straight though. KM and KJ have to be in the numerator because those are sides that are dealing with the same part of the triangle. LM and JL are dealing with the blue part of the triangle in this case. Okay, so just make sure you keep those straight, and that'll help you with this. This is the triangle angle bisector theorem. So example 3, let's look at this. What's happening here? Well, this thing is cutting an angle into two equal parts. So this is an angle bisector. That's what's happening. So if this is truly an angle bisector, I can use the angle bisector theorem that we just learned about. Okay, so I'm going to, just for the purposes of making this easier to see, I'm going to turn this into the red part of the triangle, and then we also will have the, let's just make it a purple side of the triangle. Okay, so dealing with red first. Okay, so we're going to say the opposite of this angle bisector in the red section is 4. Okay, the opposite in the purple section is 6. That is going to have to equal the opposite in the red section side, which is x, over the opposite of the purple side length, which is 13. Now we have it all set up. It's easy. We cross multiply and we're done. So we get 6x equals 13 times 4. Again, this is just using the angle bisector theorem that we just learned about. I'll let you guys finish that one. Second part to example 3, example 3b. Again, we have an angle bisector happening here. Okay, but notice we don't exactly know what each of these things are. All right, so we do know something about it, but we don't know exactly what they are. I'm going to change this again to the red part of the triangle, and then I'll just keep the other side blue to save time. So if we look at the red part of the triangle, we know that this length has to be 20 minus x, because the whole length is 20, and we have to subtract the x piece, right? So that's going to be 20 minus x, and then we'll just say it's the purple side, I guess we'll just draw it in here. So the purple side of the triangle is going to be x. Okay, so again, this angle bisector, we're looking at the opposite sides, 20 minus x and x. Okay, that is going to have to be equal to the corresponding side lengths. So looking here, the 20 minus x is dealing with the opposite side length of that, and that section of the triangle would be 11. And the opposite of the purple side would be 14. Okay, now we have this nice ratio that we can use cross multiplication with. Okay, so we have 14 times 20 minus x has to equal 11x. Make sure that you use your distributive property, distribute this out, and solve for x. All right, so that's example 3. I'm not going to do the algebra piece there for you. I'll let you finish that up, but check with a partner on it. And that's it, guys. So your homework assignment is going to be 1 through 23, odds, of course. So this is odds. I want you to skip 3 and 19. I'm going to let you skip the proof for today. And make sure that you turn in. You should be turning in your homework from last time. And be sure to label this one as homework 7.5. All right? And make sure your name's on it. I'm still getting a couple of no names. All right, guys. That's it. Take it easy. Hope to be back by tomorrow. We'll see.